In the vast, dark expanse of space, far beyond the familiar sights of the planets, lies a lonely traveler, Voyager 1. Launched in 1977, it was initially intended to perform a relatively straightforward mission, fly by Jupiter, then Saturn, and send back data on those distant worlds. Yet, as the years have passed, Voyager 1 has become one of humanity's greatest triumphs in space exploration, a testament to human ingenuity and determination. At more than 45 years old, it is still sending back valuable data, despite being over 22 billion kilometers, or over 14 billion miles, from Earth. But recently, it has started transmitting strange, baffling signals that are leaving scientists scratching their heads. Could this be a sign of a deeper, unexplored mystery in the vast reaches of interstellar space? Or is it simply another technical glitch in a probe that's well past its expected lifespan? As the confusion grows, the question looms, what's really going on with Voyager 1? Voyager 1's journey began in 1977, as NASA launched it into space on an unprecedented mission to explore the outer planets. The space probe was designed with a golden record, a sort of time capsule containing sounds and images of life on Earth, meant for any intelligent extraterrestrial life that might someday encounter it. Its primary targets were Jupiter and Saturn, the gas giants of the solar system, but the mission quickly grew to encompass much more. Voyager 1 reached Jupiter in 1979, where it captured the first detailed images of the planet's turbulent atmosphere, including its iconic Great Red Spot. These images revealed that Jupiter's atmosphere was far more dynamic and complex than scientists had previously imagined. The probe also sent back information about the planet's moons, including the volcanic activity on Io and the evidence of subsurface oceans on Europa, which would become the focus of much scientific speculation regarding the potential for life beyond Earth. After its successful flyby of Jupiter, Voyager 1 continued its journey toward Saturn, arriving in 1980. The probe sent back detailed images of Saturn's magnificent rings, revealing intricate structures within them that had never been seen before. Voyager 1 also made the first close-up observations of Titan, Saturn's largest moon, uncovering a dense atmosphere that intrigued scientists, sparking questions about the possibility of Earth-like fluid cycles on this distant world. By the time it had completed its mission at Saturn, Voyager 1 had provided a treasure trove of scientific data that would influence our understanding of the outer planets for decades to come. But after completing its exploration of the outer planets, Voyager 1's journey was far from over. In 1980, the probe left Saturn behind, traveling into the Kuiper Belt, a region filled with icy bodies and remnants from the early solar system. For over 10 years, Voyager 1 continued to send back data from this distant frontier. By 1998, the probe had reached a point where it was no longer within the gravitational influence of the Sun, officially entering interstellar space. In 2012, Voyager 1 made history when it became the first human-made object to enter this uncharted territory. The probe was now beyond the reach of the Sun's protective bubble, known as the heliosphere, and was exposed to the harsh environment of interstellar space, a vast and largely unknown expanse of the galaxy. It was at this point that things started to get truly interesting. As Voyager 1 ventured farther from the solar system, it began detecting a series of unusual phenomena. The first of these was a strange burst of particles in interstellar space that seemed to defy the expectations of scientists. The particles were much denser than anything scientists had predicted. This discovery led researchers to reconsider their models of the universe. Particle streams in open space should not be concentrated in such a way, and the fact that these particles were so close to our solar system raised more questions. Some scientists speculated that the particles might have originated from a distant star, perhaps a plasma ejection from a distant stellar event. However, this idea was quickly dismissed, as the closest star to Voyager 1 at that time was more than 4 light-years away. Plasma streams from a star that far away should have long since dispersed in the emptiness of space. Yet the particles remained, undeterred. This mysterious particle stream became one of the first clues suggesting that interstellar space is far more complex than previously thought. The density of the space Voyager 1 was traveling through seemed to be far higher than models had predicted. This was a significant discovery in astrophysics. Just a small variation in particle density can alter our entire understanding of the universe. Voyager 1 was showing scientists that interstellar space was not empty, as had once been thought, but filled with particles that could be influencing the behavior of stars and galaxies. Meanwhile, Voyager 1 continued to send back data on the cosmic rays it encountered. The increase in cosmic rays intensity was not surprising, but it was nonetheless important. Cosmic rays are high-energy particles that travel through space, and their density is used to gauge the composition and dynamics of the space Voyager 1 was passing through. This data allowed scientists to better understand the conditions of interstellar space and how it interacted with the Sun's solar wind. But perhaps the most intriguing data from Voyager 1 came from its measurement of interstellar magnetic fields. These magnetic fields were much stronger and oriented differently than scientists had expected. For years, astronomers had been trying to understand the magnetic field structures of the interstellar medium. Voyager 1's data showed that these magnetic fields could play a crucial role in the dynamics of galaxy formation and star creation. Some scientists even speculated that these magnetic fields might be remnants of a primordial magnetic field from the early universe, potentially dating back to the Big Bang. This idea, if true, could mean that these fields carried within them a record of the universe's early history, providing a direct link to the origins of everything we know today. As Voyager 1 continued its historic journey, the mission encountered another unexpected challenge in 2021. For a brief period, it appeared as if the probe had completely lost its orientation. The data sent back from Voyager 1 seemed incomprehensible, and it appeared as though the spacecraft was tumbling in space. This was a terrifying possibility, as the probe relies on its orientation to send back data to Earth. If it had lost its orientation, it could no longer communicate effectively. Yet, when engineers closely examined the telemetry data, something unusual became apparent. Although the signals were erratic, they were consistent. The probe's antenna, which had to remain pointed toward Earth to transmit data, seemed to be functioning correctly, meaning the probe was not tumbling as it appeared. This anomaly led engineers to hypothesize that a glitch in the spacecraft's attitude articulation and control system, AACS, which is responsible for controlling the spacecraft's orientation, might be causing the strange data. It was a technical challenge unlike any other. With Voyager 1 being over 20 billion kilometers away, any attempt to fix the problem would take over 20 hours to receive a response. But NASA engineers, working tirelessly, found a solution. They decided to reroute the spacecraft's internal control system and use an alternative method to correct the problem. After 20 hours of waiting, the team received confirmation: Voyager 1 was once again transmitting usable data. It was a triumph for the engineers, a testament to the ingenuity that has kept the probe operational for so many years. However, in the fall of 2023, another problem arose. This time, Voyager 1 transmitted a strange, repetitive sequence of zeros and ones, a signal that made no sense to scientists. After analyzing the data, NASA's engineers discovered that the sequence was actually a replica of the probe's Flight Data System, FDS, memory, a system responsible for storing and transmitting data from the probe's scientific instruments. It was clear that Voyager 1 was still alive, but the data it was transmitting was corrupted. NASA immediately began investigating the issue, suspecting that the FDS might have malfunctioned, but they were unsure of how to fix it. The distance between Earth and Voyager 1 presented a major obstacle in diagnosing the problem. Communicating with the spacecraft could take over 20 hours, and fixing the issue from such a vast distance was a daunting task. Despite the challenges, NASA has not given up on Voyager 1. The team is working to put the spacecraft into different operating modes in an attempt to locate and fix the problem. Some of these modes have not been used since the 1980s, when the spacecraft was first sent on its mission. If the problem is not fixed, Voyager 1's mission could come to an end prematurely. Yet, despite the uncertainty, the team remains hopeful. As Suzanne Dodd, the head of the Voyager project, stated, the team is not giving up. There are still solutions to explore, and the mission, while facing difficult odds, may continue to yield valuable data for years to come. Voyager 1's longevity, especially given its age and the immense distance it has traveled, is nothing short of miraculous. The original mission was only supposed to last a few years, but over 4 decades later, the spacecraft is still sending back valuable information. The data it provides has already reshaped our understanding of the solar system and interstellar space. Its continued operation, even in the face of technical challenges, is a testament to the success of the Voyager program and the incredible human effort that has gone into maintaining and operating the spacecraft. As the world watches with bated breath, the future of Voyager 1 remains uncertain, but one thing is clear: this remarkable spacecraft has already achieved more than anyone could have ever imagined when it was first launched in 19